Hello everyone and welcome back to this Python programming course where you are going to learn everything you need to get started programming in Python. In this video, we will look at looping structures in Python. So let's jump right into it. A loop in a computer program is an instruction that repeats itself until a specified condition is reached. In a loop structure, the loop asks a question. If the answer requires action, it is executed. The same question is asked again and again until no further action is required. Each time the loop is executed, we are said to have done an iteration. A loop statement allows us to execute a statement or group of statements multiple times. Python programming language provides three types of loops to handle looping requirements. The first one we are going to look at is the for loop. The for loop is used whenever you want to repeat a block of code for a fixed or specified number of times. The for loop is always used in combination with an iterable object like a list or a range. The Python for statement iterates over the members of a sequence in order, executing the block each time. The for loop has the following syntax. For iterating variable in sequence, then we have a statement or statements. We will look at this further in an instant. The next thing we are going to look at is the range function. The range function is very useful in Python. It occurs in three different forms. The first form we are going to look at is the form range n. This function generates a set of whole numbers starting from 0 to n-1. For example, range 8 is equivalent to a list from 0 to 7. If we print this, we will look at, let's say, 4. And we see that we have our list from 0 to 7 being printed. The next form we are going to look at is range start and stop. This form of the range function generates a set of whole numbers. For example, range 5, 9 is equivalent to a list from 5 to 8. Remember we said stop minus 1. The third form we are going to look at is the range start, stop and step size. This is a third form of the range function. The default step size is 1, which is why we didn't specify the step size. The numbers generated are having a difference of 1. However, by specifying step size, we can generate numbers having the difference of step size. For example, the statement range 1, 10 and 2 is equivalent to a list of 1, 3, 5, 7 and 9. In this case, we use 2 as step size, so after every number we have a difference of 2. As an example, we'll be creating a program to display the sum of the first 5 natural numbers. So here we see we have our program to print the sum of the first 5 natural numbers. We initialize sum, which will be the variable to store the sum of all the first 5 numbers. Then you'll be iterating over the natural numbers using the for loop and the range function. So for value in range 1 to 6, we want to work with the first 5 natural numbers. So we later on have sum equals to sum plus value to be able to keep the value of the sum progressing, like to sum up all the values of the range. Then we later on print our sum and we have 15. In Python, we can have an optional else block associated with the loop. The else block executes only when the loop has completed all the iterations. So let's look at an example. For this example, we have for value in range 5, we have to print the values in this range. Else, we have to print the loop has completed its execution. So this else block will only be executed after this for loop has completed its execution. The while loop repeats a statement or a group of statements while a given condition is true. It tests the condition before executing the loop. So the while loop has the following syntax. While expression, that is while the condition to be tested is true, then the following statement or statements will be executed. So let's have an example. We write a program to count the numbers from 1 to 10. So we initialize our count to 0. Then while count is less than or equals to 10, then the value of count increases by 1. So at the end we print count and we have 11, meaning that there are 11 numbers from 0 to 10. A loop becomes infinite if the condition never becomes false. You must be very cautious when using while loop because of the possibility that this condition never resolves to a false value. This results in a loop that never ends, and such a loop is known as an infinite loop. Let's look at an example. In this example, we are trying to generate an infinite loop. So here we have a variable var with value 1. While var is equals to 1, print good morning. So we see here that this loop will be executed as many times until the value of var changes, that is, until the value of var is not more equals to 1. But we did not include any statement to be able to change this value of var. So this results in an infinite printing of good morning, which only stops when I decide to close the program. Python supports to have an else statement associated with a while loop. If the else statement is used with a while loop, the else statement is executed when the condition becomes false. The example we are going to see illustrates the combination of an else statement with a while loop that prints a number as long as it is less than 5, otherwise the else statement gets executed. For this example, we have declared and initialized our variable count to 0. We have while count is less than 5, print the value of count, then add the value of count by 1. So each time this program will be executed, the value of count will be tested. If it is less than 5, then this part of our code will be executed. Once this condition is not respected, then the else block will be executed, printing count is not less than 5. So let's have our output. We have 0, 1, 2, 3, and then 4. Then once count becomes 5, we have count is not less than 5 anymore. Firstly, we see that they are declared differently. Then secondly, the for loop is used when we are aware of the exact number of iterations at the time of execution. On the other hand, with the while loop, we can execute a set of instructions even when we are not aware of the number of iterations at the time of execution. Thirdly, if you forget to put the conditional statement in the for loop, it will reiterate the loop an infinite number of times. But if you forget to put the conditional statement in a while loop, it will display an error message. In Python, a nested loop is basically a loop inside the body of the outer loop. The inner or outer loop can be of any type, such as a while loop or a for loop. For example, the outer for loop can contain a while loop and vice versa. The outer loop can contain more than one inner loop. There is no limitation on the chaining of loops. For each iteration of an outer loop, the inner loop restarts and completes its execution before the outer loop can continue to its next iteration. So this is the syntax of a nested loop in Python. So first of all, we have the outer loop for element in sequence. We have the outer loop. Then we have the inner loop, which is for element in sequence 2. Then we have the body of the inner loop, and finally we have the body of the outer loop. For this example, we are going to look at execution of code in a nested loop. So our program goes as follows. Okay, in this example, we have a for loop nested into another for loop. So for this for loop, we have for I in range 1 to 4, print the outer loop is currently being executed. And then we have a for loop for j in range 1 to 3, print inner loop is being executed. So let's have a look on how this functions. So we first of all see that the outer loop is currently being executed. So this is the first thing that goes. Then we go into the second loop in the inner loop and the 2 iterations, because we have our range 1 to 3 excluded. So our inner loop is executed twice before our outer loop is executed again for the second time. Then the process continues until our outer loop is executed the specified number of times, that is from 1 to 4 to 3 times. So this is basically how nested loops function. Loop control statements are keywords that eases the use of loops in Python. The first one we are going to look at is the break statement. It determines the current loop and resumes execution at the next statement, just like the traditional break in C. The most common use for break is when some external condition is triggered, requiring a hasty exit from the loop. The break statement can be used in both while and for loops. If you are using nested loops, the break statement stops the execution of the innermost loop and starts executing the next line of code after the block. As an example, we have the function, or we have the code for I in range 1 to 5, print good. But if I is equals to 3, break out of the loop. So let's look at the output, and we have good printed 3 times, whereas there are 4 values in this range. So what has simply happened is that when I turned to 3, the execution of the loop broke out. So the break statement made the loop to break out and to move directly to the execution of the next statement without printing a good. Reason why we have good printed only 3 times. So if we delete the break statement and we start the function over, then we have good printed 4 times. So this is how you can use break to be able to break out of a loop that you are currently executing. Other statements that you will not be using as often as the break statement are the continue and the pass statement. For the continue statement, it returns the control to the beginning of the while loop. The continue statement rejects all the remaining statements in the current iteration of the loop and moves the control back to the top of the loop. On the other hand, the pass statement is used when a statement is required syntactically but you do not want any command or code to execute. The pass statement is a null operation. Nothing happens when it executes. Pass is also useful in places where your code will eventually go but has not been written yet. This is basically it for this video, but before we end this video, I am going to paste a practical exercise here for you to keep learning and implementing the concept of looping structures you just learned today. The link to the solution to this practical exercise is attached in the video description below, but before checking it out, make sure you try writing the code first. In our next video, we are going to look at input and output statements in Python. So, see you soon.